I'm really excited to be here talking with you about incident response and incident diagnosis, and focusing on like building dashboards that will kind of help you through that process. Monitoring dashboards are like one of the biggest windows that we have into our infrastructure, and they're where we turn when things go wrong, when we're asking like, oh no, what just happened? And yet a lot of times like we kind of do a half-hearted effort and leave stuff on the backlog and don't really get to them. I don't really like that because I love building dashboards, and I love building graphs that do that, except in a good way, not in like an outage way. So I don't think that should be, but I'm not here to convince you that that is like should be a passion of yours. What I am here to talk about is like how to kind of maximize your investment, so that if you don't like doing that, then you can like spend a little bit of time thinking about these things, and then hopefully you're better off for it. So there's a lot of reasons that you'll build a dashboard. Today I'm focused specifically on incident response. And I have a couple of notes before I begin. I'm going to show some dashboards from a couple of different vendors. I'm not a salesperson. I'm not affiliated with them in any way. It'll probably be obvious which one I really like, but that's okay. And nothing in this talk is really going to be revolutionary. It's really like looking at kind of how we think about things and trying to help ourselves. Hello? There we go. So a little bit about me. I've been doing ops for like a lot of my career and doing some product development along the way. I've been to 6 DevOps days so far. I was at the original one, or the first one in North America in 2010. My new boss at the time was like, hey, we're going to this Velocity conference, get a ticket. And oh, by the way, there's this DevOps thing that's happening afterwards, and I'd never heard of it. So I was lucky enough to get a really early introduction there. So while this is my 6th, this is my first time talking at one, so I'm like a long-time listener, first-time caller thing. I work at a company called AdHoc. AdHoc is a software engineering company that came out of the successful effort to rescue healthcare.gov after its disastrous launch. We develop, deliver, and operate fast, stable, and well-designed digital services on behalf of US federal and state governments. And in particular, I have the privilege of working on this site, which is called vets.gov, which is a transformative project for the VA to increase information, benefits, and services to veterans and their family members and their affiliates, and help them navigate these complex processes with empathy and human-centered design and language. And sometimes people's eyes glaze over when I say government, but we get to do really cool things like daily deploys in a federal government space, which is pretty fun. So I'm not really here to talk about that, though. Well, here, I would love to chat in the hallway if you're interested, but I want to dive in a little bit on a little bit of my motivation and why I think this is a really important thing to think about ahead of time. And I have a mission for this talk. And this talk is to help you minimize time spent on emergencies. And often, like, spending time on unplanned work is a common thing in DevOps and Agile initiatives, or whatever you want to call them. But that's not really what I'm talking about. I'm talking about like real emergencies, like what's going on, everything is broken, site's down, whatever. So I also recognize that prevention, what is it, ounce of prevention is worth a pound of cure. While that is definitely a major way to get there, or to reduce that amount of time, there will be emergencies because production happens, stuff goes wrong. And I have 2 kind of primary reasons to focus on this. The first is organizational. So you probably care that like your organization's service is running. If you don't, you probably at least care that they're like successful enough for you to get a paycheck. So there's that. But there's a second reason that I think is ultimately like more important, and the thing that I want you to kind of share here, which is that any time you spend responding to emergencies that you're getting paged and going through that is time that your career goals are on hold. And there's this really good talk from someone named Alice Goldfuss last year at Monitorama. So if you ever need some motivation to clean up your alerts, go watch that talk, and I'll link to it in the end. And that was kind of where I first really went, oh wow, yes, this is really, really important from that perspective. And so first I want to talk about how we diagnose incidents. I'm going to walk through this academic paper that was written on the heuristics of diagnosing incidents. And so my hope is that by thinking ahead of time about the things that we're going to be looking for and the way that we're going to think about things and the mindset that we're going to be approaching, we can invest our time wisely into these systems. So I'm using this paper called, it's a mouthful, Trade-offs Under Pressure, Heuristics and Observations of Teams Resolving Internet Service Outages. It was written by someone named John Alspaugh. You can't go to a DevOps conference without a reference to John Alspaugh. I haven't heard one yet, so there you go. You can check it off on your bingo card or whatever. He was CTO of Etsy at the time, pursuing a Master's of Science in Human Factors and System Safety. And this document walks through, does a case study of a real incident that happened on Etsy.com. It was about an hour-long outage, a little bit longer than an hour. And it happened 3 days after Cyber Monday in 2014. The homepage was in some sort of degraded state, so a website with a homepage that's not working properly during the busy shopping season is not good. And so that's about all that I want to talk about, the context of this study. There's another great talk also from Monitorama last year by someone named J. Paul Reed that goes into a much more depth. If you're interested in hearing more, that's a fantastic spot. Also, we'll link at the end. And so this paper identified 3 heuristics that were used to diagnose incident. There's a 4th in the paper, but it's not really relevant to what we're going to talk about today. And so the first one is the engineers asked of themselves and of their systems, I guess, what did we just change? And it was unanimous. They all said that they did the exact same thing first. And they didn't do anything else. They didn't look at any other, they didn't go in any other places. It was very consistently, that was the first place they went. And most of us probably intuit about this. And in fact, this study actually mentions that only 2 of them ever explicitly said in IRC, this doesn't line up with a deploy. So that was kind of an interesting thing. And so they're looking to correlate some sort of change in the system with these this new emergence of these symptoms. And the second one is titled Time to Go Wide in the paper. And it's really about getting this wide view as you possibly can. You're kind of getting this state of the world and formulating some sort of opinion or theory of what's going on, and then diving in to disprove that theory. And if you prove it, I guess you're done. But if you disprove it, then you start over and you just kind of go in this tight feedback loop throughout. And the third one was called convergent searching, excuse me. It plays into the first, and it's really about kind of what engineers are looking for when they are going wide. And what's kind of interesting about this is they're actually looking for things that happened to them in the past, whether it was a really, really painful and vivid memory of something that was really hard to diagnose, or something that happened very recently. And when they're looking at the old or the painful memories, they're looking at very specific symptoms. The recent ones are more kind of generic. And it's worth noting here that they did so and asked questions even without a lot of evidence sometimes that the thing that they were looking for was in fact this. They just kind of pattern matched the symptom, went right to it and said, I need to disprove this. And so these are the heuristics. I changed the wording just slightly. What changed, go wide then go deep, and what has happened to us in the past. And so with this in mind, and this kind of context and our frame of mind, I want to talk through some of the things that I've used and I think should be the way to go. Some of these I haven't implemented yet. They're like things that I kind of came up and went, oh, this deserves to be in a talk, and so I haven't gotten through all of them yet. But so the first question is what changed, and I mentioned it seems like the thing that we really intuit, like who broke it, is like this common like first response, and yet I've implemented them twice in places that I've worked. So while it may seem obvious and something that you should do, it's maybe not done all the time. And so if you don't have this, definitely a good first place to go looking. A common thing that people do is they have these like vertical markings on a graph called, they call them deploy lines often. But a thing that I've found as I work through them is that deploys are not instant. So you're not going to go from like version 0.0.1 of the software 1 second and version 0.0.2 in the next second. That's not really how the world works typically. And so you usually will have some sort of like time range where that deployment is happening. Either you're spinning up new infrastructure to replace the old, or new app servers to replace the old, or something along those lines. But it's rarely like, sorry, I picked up a cold and my my voice is kind of funky. It's rarely like that instant thing. And so the other thing that I want to talk about is like deploys are not always the only type of change, and they're never the only type of change. There's lots of like little ones, like maybe your environment allows like a super user or admin to like turn on something that changes the performance characteristics, or you know, in our environment we use Terraform and Ansible. Ansible does management of like more dynamic resources. It manages autoscale groups and the versions that's running inside of them, and does rolling deploys and things like that. But Terraform manages the more static resources like security groups and VPCs and elastic load balancers and stuff like that. And so we build these like annotations using Ansible, but a blind spot that we have is from Terraform. Like we don't do a very good job of that. So I wanted to show an example of kind of what that looks like, and the sort of funny thing here was I was going through my slides last night, and I was like going, this screenshot doesn't really show very well the time range, and so I actually noticed. So I zoomed in on one, and I was like, oh, that's actually probably a problem during the deployment. So there you go. This is like, I mean, this is a real screenshot of a real thing. I just removed some labels. I don't know how well you can see that, but one of the things that I wanted to point out that I did as kind of a nicety on there, this is Grafana. When you mouse over the little block, it pops down this thing that tells you some information. And one of them is if it detects that there's like the Jenkins build URL environment variable, then it shoves it in as a link, so you can click that and say, oh, why did you do this thing? So that's kind of nice. And I found another one. This is a product called Sumo Logic. I actually talked to them in the hallway yesterday, and they showed me this feature where they do it a little bit. They have a little bit of a different implementation here. They're kind of mixing like metrics and logs, which is really nice and useful for this type of thing. But this is less like static events, and this is more like events that happen more frequently. So you might imagine like a spike in CPU and then suddenly like tons of errors right there. You don't necessarily have causation, but you definitely have correlation. So that's one way. And again, I'm not trying to pitch any vendor. And so the next heuristic is called go wide, and I'm adding on then go deep. And this is kind of a long slide, but I want to like kind of paint this out a little bit broadly. Nothing earth-shattering. Nobody's like going to go, you know, whoa, we're doing everything wrong or anything like that. But definitely worth like explicitly thinking about and talking about. And so the first thing that I've found is that you really need like the one wide view dashboard for whatever it is that you're working on. It might be that just for like your department or whatever, but you need like one kind of world view thing. And the things that are important there are latency, throughput, and errors. And I'll talk about that again in a moment, and I'll show another example. And just to kind of paint the picture a little bit, on, let's say you have a monolithic web app, you might care about like DNS responses, or you want this for every layer, so you might care about like DNS responses, load balancers, app tier, database tier, search tier, whatever, whatever your environment entails. And the other thing about wide view dashboards I've found is that you want to be very explicit about the data source when there's like multiple places that can be measured. So a common example would be like if you have a load balancer that has app servers behind it, and you see like a dip in requests per second behind it, or like at the app server tier, but not at the load balancer tier, that's a very different problem than just like requests dropping off altogether. And so putting those things close together and like being very explicit about those labels, because again, you're trying to get through this list as quickly as possible. So then we kind of like formulate some sort of theory, and then we go dive deep. And you're going to want like, this really depends on your environment. You might know like a region or location specific thing, and this might be a filter on your wider view dashboard. But then you also want like node specific things, so you can dive into, okay, I need to check out CPU states on X node as an example, just kind of see what's going on. So you really need that. The application, or the node specific and the layer specific are where some of the pre-canned dashboards may really help you kind of get started. You know, every environment is a little bit different, so you can't always just start with like some pre-canned thing. But that's an area where it can really shine. And layer specific here means like at the different tiers. So let's say you run an Elasticsearch cluster. You might care about the metrics that Elasticsearch cares and be able to dive really deep into the Elasticsearch cluster and how it's behaving. And then application and product specific is like, maybe you want to break it down by, say, you're shipping microservices and you care about that. Maybe like you manage several of them versus, you know, this wider view. And the last thing on this specific thing before I go into examples is include limits whenever possible. And this one seems like, okay, that's kind of basic. But limits can be really sneaky. And they can be sneaky because you might have like a license limit, like a lot of network devices might have a 10 gigabit Ethernet interface, but because of software licensing, you can only get a gigabit out of it and things like that. And also, like as a pro tip, to maybe save you some diagnosing later, a lesson that I learned really hard, or the hard way, was the disk throughputs on AWS resource nodes. For EC2 and RDS and all of those, they have a disk throughput published. And those are fully duplexed. So if you are like doing lots of reads or lots of writes, you only get half of what they actually publish on one side or the other. So that's kind of that can be a sneaky one. So this is kind of an example of a wide view dashboard. There's nothing like earth-shattering about it. I'm sharing it for a few reasons, and pointing out like we have like the deploy line thing across the top. You can check or uncheck that box, and then also I'm showing on the left-hand side there's a couple of graphs on the bottom, which are latencies. We run a government website which has a federal mandate that it has to be behind what's called a trusted internet connection. So this is a comparison between like what our infrastructure sees and what we see through that connection. And so you can easily see right here, like we had some sort of problem here where our infrastructure was doing fine, but there was some other issue like going through that connection. And if you're a little bit stuck and not really sure how to go about doing this, there's a fantastic resource that I want to share, which is called the USE method. It's USE, stands for Utilization, Saturation, and Errors, developed by someone named Brandon Gregg. I'll have a link to it at the end. But I found this dashboard from a company called Circonus, I think is how you say it. They actually like implemented this as like rows of resources and then columns of utilization, saturation, and errors. What's sort of funny to me about this dashboard is that and the use method in particular is that if you look at the workflow in the documentation, it's actually errors, utilization, and saturation is the workflow that you're checking. So it's actually like all of the letters in the wrong place. And so you have like this thing that doesn't actually follow the workflow, but it does lay it out very nicely. And another thing that I kind of respected here was getting CPU errors is kind of tricky. So they, as a vendor, don't collect that. But then they have, I don't know if you can read that, but I would say it's documentation on how to get a CPU error, but it's not exactly like copy and paste. But they at least like provide a hint in the right direction. So I like that acknowledgement that like, you know, this is here. And the use method can be applied at an individual node level on like physical resources like CPU, memory, disk, et cetera. But it can also be used on like at a higher level, like at the process level, and also like in network systems. So it's kind of a useful tool to know if you've never seen it before. And what has happened in the past is the next heuristic that we go through, and I think this is the most important thing to like keep in mind. All the other stuff I feel like is pretty easy to intuit about, but this is probably the most surprising and the most interesting, and the thing that I want you to take away if you take nothing else. And just keep in mind that when you're diagnosing those incidents, when you're diagnosing an incident, you will be thinking about those past incidents. That's how our brain works. We're not like studying this to hack our brain. We're like studying it to understand it and work with it. And so you can help yourself by creating like dashboards that you might need, and things that you might be thinking about as you go through outages. And this can be like personal, or it could be group wide. So, you know, you might have experienced an outage, and everybody now knows like on one project that I work on, we have this like hard-earned lesson of like what to do and what not to do during database migrations, and I think everybody goes through that. So that's something that the group kind of shares, but there's also like the individual stuff as well. And so this pattern matching thing, like your brain goes, oh, wait a minute, I've been here before, I know what this is. It can be helpful, and it can also be less than helpful. So it can be a trap, and so what I'm advocating for is to give yourself a way out of the trap. And I want to share like an example of how I might, how I might apply that to myself and a thing that happened to me in the past. And so I have like this war story, I guess. But years ago, I was working in this environment that ran MySQL clusters, and we were upgrading from 5.1 to 5.5, and we did a pilot run. We like stood up new clusters, and we're bringing customers over kind of slowly, and we brought in like 10, and then 100, and then 1,000, and so that first day that we had like a really big load, we were like just working on an afternoon, and all of a sudden we got paged about request latencies. And before anybody really logged in and was able to respond, it started flowing again. And so this proved to be kind of difficult. We went to like system level metrics seemed fine, everything seemed normal. There were no like events that were logged that seemed correlated, and slow query logs were like not really that useful because it was difficult to understand what was symptom and what was cause. And it turned out that it was this new, depends on how you want to dress it up, bug or feature in this version of MySQL that we happen to be running in our configuration. When you did a drop table, it would freeze the entire buffer pool and remove every reference to that table out of the buffer pool, and then unfreeze it again. And so that was like a probably like 2 days of going, what is happening? How could this be? It wasn't. I didn't find anything published about it except for like one obscure bug report that took us a while to track down. And so this is a memory that sticks with me because I I had to debug this and think about this for a long time, and so it's one of the things that I come back to. And we had graphs for like queries per second, and you can kind of see like, this is just simulated data, but you can kind of see like the top 2 lines are like select and update queries, and the bottom line there is drops. And you can see this little tiny little blip maybe. I can barely see it on my screen when it's just on here. I don't know how well you can see it over there, but. So a way that I think about this kind of thing is to shift the visualization a little bit to make it just more obvious to me in the future, to kind of give me that comfort that I can go and look and have it be really obvious. And so what I would do here is change the graph a little bit to shift some of those rare used events over to the right side so they become like an event. And they're just a little bit more visually stunning. It becomes a bar instead of a line and that kind of stuff. So that's one of the ways that like I take that concept and kind of apply it to myself personally. And the last thing that I want to leave you with is a little bit of encouragement and also like just a career pro tip, which is be curious and ask questions. When you see like dumb little things where you're like, why is the drop over on the right side? That's ridiculous. There's probably a story. There's probably like someone went through some stuff, learned what happened, what was going on, and how they could like help themselves out by doing that. And so there's probably a great story or lesson, or maybe, you know, the person who built that dashboard doesn't know how to use the monitoring system, you know, either way. But there's probably a great story there. So to recap, why do we care about dashboards? The biggest reason that I care about this and want you to care about this is that while you're diagnosing these things and while you're getting paged, you're putting your career on hold. What are the heuristics, what changed, and then we have go wide, then go deep, and what has happened to us in the past. And some tips for faster dashboard response, in particular the use method and the like adjusting your dashboards for past experiences. So I have some links to stuff that I referenced, and that's it. Any questions?